So the next concept is asynchronous sequential circuit. So the thing is, you need to know what is the difference between synchronous and asynchronous. Okay, sequential is something like moving on in one particular order, like first 0, next 1, 2, 3, 4. That's a sequential circuit. Okay, in a proper order. Either it might be ascending or descending order. It might be. So moving in one particular order, like 0, 1, 2, 3, 4. That's a sequential circuit. What is synchronous and what is asynchronous? So the thing is, so in the previously you just saw like a D flip-flop Q plus. Okay, you're passing 0. So the okay, so here we have a clock pulse. Let me assume this D flip-flop is a positive edge trigger. The change of state should occur only the rising edge from when it moves from 0 to 1, not from 1 to 0. Okay, so the change of state should occur only positive. So right now the present state is 1. Okay, so I'm passing D is equal to 0. Okay, the output should be 0. The output should be 0 because I'm passing 0, so output should be 0. So this change of state from 0 to 1 should occur only during the positive edge trigger. So when the clock pulse moves from 0 to 1, so then only it should change 1 to 0. Not, it should never changes from 1 to 0 during the falling edge. So this change of state moving from 1 to 0 with respect to the clock pulse we call as synchronous. Taking the clock pulse into the consideration, change of state occurs with respect to the clock pulse, that is what we call synchronous. Okay, I'm not taking anything with respect to the clock pulse. I'm passing 0 and the present state is 0. The next state will be 0. So without taking the clock pulse into the consideration, I'm changing the state. That is asynchronous. That is asynchronous. Okay. Keeping this in mind, they have given a circuit like this. Okay. They have given a circuit. Okay. So they have they have given an explanation telling that in case of asynchronous circuit, if you want to have a sequential manner, if you want to change the states in the sequential manner, like 0 after 0 after 1, 1 after 1 it should be 2, after 2 it should be 3, in a proper manner, in a synchronous circuit we are supposed to put some restrictions. We are supposed to add some restrictions, because in case of synchronous circuit the change of state will be occurring with respect to the clock pulse. There won't be any problem. Okay, but in case of asynchronous, there won't be any clock pulses. We were not taking the clock pulse into consideration, and the change of state should occur in a proper manner, like in a sequential manner. Then there might be a chance of it might be going wrong. Like why it is going wrong means there might be some hazards. Hazards means some issues. Hazards refers to why these hazards means there will be some delay, like passing the data from here to here. There will be some delay with respect to this gate. There will be some delay with respect to this gate. So we will be having some propagation delay with respect to each and every gate. Okay, changing the state. So if we keep on considering the delays with respect to each and every gate, so while it producing the output, there will be a lot of delay. Okay, we can't predict. We can't predict like of 0. After 0 it will be 1. After 1 it will be 2. After 2 it will be 3. It has to be in a proper order. It has to be in a sequential order. But due to these sort of delays, in case of asynchronous, we can't predict it will be in the proper order. So we are supposed to put some restrictions in order to make this asynchronous circuit to work in a proper sequential order. We need to add some restrictions. Without restrictions, there will be some hazards. There will be some problem. That is what they are given. Like there will be a like static 1 hazard, static 0 hazard. There are some hazards which you are going to learn in the next upcoming classes. What are hazards and all those things. Hazards are something due to delays, due to some propagation delay, the change of state occurs bit later rather than expectations, right? So I'm passing D is equal to 0. It has to change to 0, but it won't change immediately. It will change after some time. By that time, so the output will be taken in some other directions. Okay. So if that happens, the final thing will be the result thing will be wrong. So due to these propagation delays, that is the problem with respect to asynchronous sequential circuits. Okay. So in order to make you people understand this, they have given a simple circuit diagram like this. So they are given an equation. This is a P plus. Okay. This is a Q plus. What is a P plus? P plus is equal to X bar P. Why this is X bar P? Look at this this, what is the input for this AND gate? One is, this is X, okay, this is X. When it comes here, X bar, so the one of the input for this AND gate will be X bar. So other input for this AND gate is from P, so they have written X bar P, okay, plus, so this is one input, okay. Why this is plus? Because this is an OR gate, X cube. So look at this, one input is from X, so another input is from Q. The input for this AND gate is X and Q, so that will be added as an input for this OR gate, so that is X cube. So P plus is equal to X bar P plus X cube, okay. Similarly, Q is equal to, look at this AND gate, one input is from P, so this will be converted to P bar, okay, here it is P bar. So another input is from X bar P, this is X bar P bar, plus X cube. Look at this, one input, this is X from Q, so X cube. These are the inputs. So based on this circuit, they have written these two expressions. So first they have taken XPQ is equal to 111. XPQ means P and Q. This is 1, this is 1, and this is X is also 1. What happens? XPQ is equal to 111. So let me assume XPQ is equal to 111. PQ, here it is, Q is equal to 1, P is equal to 1, and X is equal to 1. Okay. So if I take X, P, Q is equal to 1, 1, X is equal to 1, P is equal to 1, and Q is equal to 1. Okay. Let me analyze this. So this Q is equal to 1. Look at here. I am writing 1 here because we have a feedback line here. So then P is equal to 1. We have a feedback line as well here. This is also 1 because P, and this AND gate, this will be 0. 1 will be converted to 0. So okay. So then this X is equal to 1. This will be converted to 0 here. This will be 1. This means we have a connection from here. This will be 0. So 1 0 is 0, 1 and 1 is 1, 0 and 0 is 0. So 0 1, 0 1 refers to 1, 1 0 refers to 1. So right now PQ is equal to, so right now what I have taken, PQ is equal to 1 and 1. So PQ is equal to 1 and 1. So if I am going to pass 1 as X value as 1, okay, it will be 1 and 1. Okay, if I change now X value from 1 to 0, okay, right now I am changing the X value. So now it is the output is 1 and 1 itself, so I return left as it is. So now I am going to change X is equal to 0. So if this is 0, this will be, wait a minute, okay, if this is 0, this will become 1. Okay, this is 1, 1 and 1 will be 1. So if this is 0, this will be 1 and this will be 1, and if this is 0, this will be 0. 0 and 1, 0 and 1 is 0, 1 and 0 is 0. So we have 1 and 1 is 1, this is 1, this will be 0, this will be 0, so this will be 0 and 0 is 0, and 1 and 0 is, in case of OR gate, 1 and 0 is 1, 1 0, we are going to get 1 0. So now P is equal to 1, Q is equal to 0. Look at here. So when P is equal to 1, Q is equal to 1, X is equal to 1, okay, we got 1 and 1, so remains in the same state. That is what we call a stable state. When I change from X is equal to 1 to 0, it will move to 1 0, 1 0. So now the state will be moved from 1 0 to, it comes here 1 0. So now pass X is equal to 1, it will move to 1 and 0 0. Similarly, trace out the similar manner, it will move to 0 0. So then the state will move from 1 0 to this state. Pass X is equal to 0, this will be 0 1. So right like this, it has to work in a sequential manner, switching from one state to another state. But actually the actual thing is So first it comes 0 0 0 1 1 0 1 1. It has to go like this. So if there is some alterations like first 1 1 1 0 and then 0 1 0 0, this is not a sequence manner. This is not a sequence manner. This is sequence manner. This is not sequence. So there might be a chances the sequence might appear like this in case of asynchronous. That's because of the delay with respect to these gates, the propagation with respect to these gates. So we are supposed to add some restrictions with respect to overcome these sort of hazards. Hazards refers to problems. This is just an assumption. So they have not given clearly what has to be done. So asynchronous sequential circuit, just know the thing like what is the difference between sequential and asynchronous sequencing. So whatever I just explained, they have given the same explanation here. So no need to go in detail with respect to this particular concept. That's it. This is the end of flip-flop chapter. Okay. That's it. So this is important. Additional flip-flops with additional inputs is important. This asynchronous sequential circuit, this is not much important, but you need to know how this particular circuit is going to work. You need to analyze by using this table, the same table which I just told, the table which I just analyzed, the same thing. So they are given here, the same thing. So they have rounded the data because so there is no state in the change. When PQ is 0 1, if the x value is 0, it moves to 0 1 state, the same state. So we call this stable state. If your PQ is 1 and 1, if x data is 1, it will move to 1 1 state. Though the thing is the output never changes. We call it stable. So they have made a round mark here. That's it.